All right, cross your fingers. Anyway, basically, all you got to do is replace these parts with an appropriate surface mount part, and you end up with a board that's surface mount versus through hole. And there's nothing saying that you can't mix through hole and surface mount parts on a project. Nothing at all. Let's see. I had a double-sided version of it here, and there's the top, and no, we didn't run any traces on the bottom, but basically you can shrink this guy. That's a 1-inch square circuit board with mounting holes, with 8-inch mounting holes. So you really shrink this stuff down if you're trying to squeeze it into a pill bottle or something. You make that board any shape you want, and I did put a few vias in there just to connect the ground planes from the top to bottom. And we already covered that in class, and also to connect this fill right here with the ground plane on the bottom. And otherwise you get an error without that saying, hey, you don't have the ground connected on your 555 timer. Does anybody have any questions up to this point? No? All right.
We start from the beginning.
Sure. I thought about it, and I had visions of, if somebody wanted to work on a project or something, that we could do that on group meeting on Saturday at the EOC. Fire up a laptop or something and tie it into the big screen monitor so people can see and work on a project or whatever. Let's see.
Well, I'm kind of anxious to find something I need to build so I can actually do one of these. But right now, I don't have anything on my list.
Yeah, just remember to shop OSH Park as well as the other vendors when it comes time to get a board, because they might be cheaper. But if it's a larger board, then chances are no, they won't be. But do shop them as well. So
that was interesting. Not to change the subject,
hey
but
happy Monday today.
I got to figure out what's going on here.
On YouTube that you directed us to China, the China manufacturing of PC boards was interesting.
Yeah, that was one of the vendors that I've used in the past.
The library loader, you have to fill in all the information, like the account details and that?
Depends on how you go into it, whether or not you need an account, I think. If you're accessing it, there's two different ways to access that. We'll get onto that in a minute.
Okay.
I want to import this third-party library for the Arduino. There it is. Let me open that file location so I'm in the folder where it is. Okay, so if I extract this folder, it's that quick, and drill down, we've got two files here that we're concerned with. The ELI file, that's the part. The library is the pattern file. So we've got two files there. So let's add those as libraries. And we don't import those. Here's all the types of files that you can import. But we go to library setup and we just point to them because they're already in a format that DipTrace knows. And let's see, where's library setup? Right here, over here, library setup, and we can add those into user components. And let's add a library. And we'll go to the group class because that's where I've got these particular files. And if you don't like where something is, or you don't like a particular library, you can always delete it. So here's the ELI file. And there it is, Arduino right there. And if we say OK, that should be there. And then right here, you'll see the Arduino library shows up. Now that was cool, that worked. And I use nanos a lot. So I click that. Look how big that Nano is compared to our 555 board. It's huge. That takes care of that part. That was the PCB. Let's go to the schematic capture. We'll get the other part. Go to library, library setup, user components. Let's put it under user patterns. And we'll add a library again. And go back up to the desktop. And here's group class, project, drill down, and here's the lib file. That's the shape. And here it is in the list. And we say OK. So now we've got both libraries loaded, and we can look down through these parts, and you can see in the lower left corner of the screen here, we've got the schematic symbol. So here's the Nano. You click once and put it on your screen just like any other part. And then there's the pattern that's attached to it. And it's not a pads with similar numbers are in conflict. So he's got some issues with this particular. He's got some grounds and stuff that are common and tied together, and I don't think they should really do that on there. But there may be a way around to fix this particular issue. But it doesn't show like a picture of the USB connector and things like that. And you could go in here and you could edit this pattern and draw one in for yourself. So it might be something you want to try and play with after the fact. But that's how you add the library, some third-party library that's set up for that. Now we'll go into the library loader. So if oh darn. All right, I'm gonna have to search for it. Do it the hard way. So to start off with, you need to have the library loader up and running. And there's some settings that you can set in there. And also you can set like a download folder where, when you download something, where you're going to put it. And I put mine, there's some different places that you're going to find files, but I put it in the downloads folder, DipTrace, and third-party libraries and Mauser parts, because it's always going to, typically for me, it's going to be a part that I get from Mauser. And you can put it wherever you want to, but it'll extract all the pieces of that part into that folder there, and then you can import those library parts into your drawing program. You can need to pick which drawing program you're using. In this case, we've got DipTrace. And this basically stays up and running anytime you want to be able to download a part. I thought I saved a link for that part. There it is. So I just picked an example part, and not all their parts are going to have this, but if you look here, it says ECAD model in the middle of the page here on Mauser's website, and it shows PCB symbol, footprint, and 3D model. And you can click on that, and they will show you what they have for the artwork for that particular part. If they don't,
cool.
Yeah, if they don't, you can request that they give you some. Now, I have learned the hard way that you take these with a grain of salt, because there are some that have errors on them, and they have a link here that says, see an error at the upper right corner of the screen. You can send them a message and say, hey, this is wrong. And I ran into that on and I sent it out in the email, an SI4707 radio on a chip, 3mm by 3mm radio on a chip. And they had the wrong artwork of that rascal. I downloaded it from here, and then like, that doesn't look like the data sheet at all. So be sure you compare your stuff to the data sheet. Now this one's fairly simple and straightforward. It's a dip package, but it makes a good example for downloading a library. So if we click download, and then it pops up a window and says, where do you want to put it, right? And this is our class project. And I've already downloaded it right there, so we won't do it again, all right? Well, heck yeah, let's do it again. Why not? Replace it? Yeah, let's replace it. So it's in that folder, and now I can go down here to we're actually done with the web page here. And I can go down here and say open ECAD model. And here's my Mauser parts folder. And let's see if we can find it. Did it put it there? Nope. It's up in the desktop in our class folder. Right there. So we're going to open that up. And it will default and pop up some instructions on importing this stuff. Let me show you that screen here. This popped up on my right screen, so I got to drag it over here so you can see it. But it'll continue to show you these instructions each time you download a new part until you uncheck that on that very first window that you uncheck Show Library Import Instructions. And it'll take you several tries before you say, okay, I'm done looking at the instructions now. I know how to do it. But they also, one of the settings in the DipTrace in the downloader there is you set the location of the 3D models. And depending on whether you're running the 64-bit or 32-bit version, depends on whether it's in C:\program files or C:\program files x86 folder. You'll find a subfolder under there called DipTrace and Models 3D, and that's where the 3D models live. And you've already downloaded some 3D models that will be in that folder. So anyway, when I open that, if we go back to this little window here, it shows the part. It says, hey, I processed that for you. So I'm gonna highlight that name and copy it because I'm gonna use it several times here. I don't want to have to type it every single time. So I think it put the parts down in downloads. Here, let's look. See the individual library pieces here. Downloads, DipTrace, third-party libraries, Mauser parts. And there they all are right here in the middle. The SN74 AHC T125N. So there's a WRL file, an STP, STI, EPW, ASC. The ASC is an importable file into DipTrace. And this is where we'll use the import function. We'll bring up the component editor. And we'll go to library and we're going to import a DipTrace ASCII file. And here's the ASCII file right there. And we say open that. And by default, it says it'll put it in other libraries. And that's what the instructions will tell you to do. And here's my part and the pattern. And you can save at this point. And it says, what do you want to call that library? And it'll save it as an ELI file. And so here's where I just paste in the name. I don't have to type it again and save that. Now that library's saved. And that ELI file can be added to the library if it doesn't show up. Just like we added the other ELI file. Let's pull up the schematic layout here. See if we can filter for that part. All libraries. Again, we'll paste here. I hate to type, so I tend to cut and paste. Wow, there it is. Look at that. Miracles do happen. So we click on it. I just left click on it once, and here's our part for our schematic. And you can double click the part here and look at the attached pattern. And right away I saw that this line wasn't lined up like it should be compared to the bottom one. If I was drawing it, I would make an outline for the chip socket around there, but you don't have to. Or you might look at the data sheet for that part and make that the outline of the body of the chip, less the pins, they'll give you dimensions on all that stuff. And you can go in and edit this stuff. The parts editor, I will send you a link to a real nice video. A guy did a much better job than I probably would do as far as showing how to use the part and shape editors. And he makes a couple of real simple parts and makes it look really easy. So if you do have to create a part, that video will be invaluable to you. So if I forget, ping me, say, hey, where's that video you promised us, right? So that's pretty much it. I think thing I want to cover on the drawings and stuff. One thing you can do is you can import schematics and artwork. There's an import here. We could import an Eagle schematic. And so that's fun to do. Look at how another program works. Let me delete that. Let's see if I've got right here is the files for the. So let's see if we can import those. Import Eagle schematic right there. Let me squeeze that down a little bit. And it tells when you close the library loader, it says, it's still running. You didn't actually close it. You just basically minimized it. And so you may, it does the best it can as far as importing a schematic, but it seems to do a fairly decent job as far as getting parts in and that kind of thing. And you may have to tweak some things here or there, but this was a breakout board that SparkFun had. It's a weather radio. And this little chip here, the SI4707, turns out is a 3mm by 3mm package. Let's see if we can import the artwork too. Just create a new one. And we'll import an Eagle board. And there's the BRD file right there. And I wish they still sold this because I would buy one. This particular drawing program, he's whining about a few things. There's some rat lines there, but the copper pores are not in this either. So here's an 1/8" stereo jack up here at the top. I think all the parts are like 805. Let's see. No, I'm sorry. They're 402 parts. 0402 is their size. So these are probably about 1/4 of the size of the ones that we were dealing with. And this particular board,
Wow.
they're saying it's 1 1/4" square. And this was a breakout board they sold for around $25. And it gave you a weather radio that would handle like same codes and all that good stuff. And the only reason I stumbled on this was that my weather radio went kaput and was looking for solutions for that rather than buying another Midland weather radio.
Is that designed to put a header on it and plug it into an Arduino?
No, it's just a breakout board. You got the individual pins here at the bottom. We can go back to the schematic here, and they show those here, the I/O pins. But I had visions of getting something like this. I found data online of all the codes and that sort of thing. That and one of these chips actually decodes those same codes, tells you what the message is and stuff like that. They've got some code written for this for the Arduino, so I already got the sketch written. It was like, oh man, they already did the work. And then I looked on SparkFun's website and they quit building this board. That got me into playing with it and importing it into the drawing program. that sort of thing. See if I could create some Gerbers for it and upload those. But then I ran into the chip being the wrong footprint and stuff. So that opened my eyes as far as those downloadable libraries. So we can actually I actually went through with and took the data sheet and fixed that the artwork, and it was kind of enlightening as far as what the this editor would do. And here's the pattern right here. Let me open this pattern. And you take that thing and you can blow it up and put dimension lines on there. But this sucker is tiny if you look at it on the PCB layout. There's that chip right there. And that's a part that I don't think I could place manually and get it right. It's just too small. This one over here, I could solder that, no problem. But you get down to something like this, and that's almost got to be machine placed. I think they probably just had a bunch of boards built. But these pads were all the wrong size, and they weren't the right shape. And I was able to go in and tweak all that stuff in this editor. You can look at like the pins and stuff and the type. And they show the shape. They weren't D-shaped pins. They were rectangular pins, and just all kinds of stuff that you can tweak here. And it turned out to be a usable pattern. Well, later I found this this chip was actually in the library. I didn't realize it. It was I think it was under RF modules or something in one of the libraries. I stumbled across it. So you never quite know what's in there, but and let's see. I think there's a show pin numbers here too. Pad numbers. There we go. So it shows you the pad numbers, and this pad in the middle is actually pin 21. Then we start with pin 1. So if you're downloading a part and stuff, I would highly recommend checking it against the data sheet. Make sure what you're putting in your schematic is going to match your part. And when you're doing these boards, print out a copy of the artwork and then lay your parts on it and make sure everything looks like it's going to fit. You will save yourself some heartache. There is another form factor of this series of radio chips, and I took one and threw it on a PCB layout and printed it out. Let's see if I can put it. Here's the sheet of paper here, and here's the footprint of the chip. And let's see, let's compare that to, there's my finger. Now that's solderable. You can solder that. It's called drag soldering. You put lots of flux on the pads, and you put a drop of solder on your iron, and it can be a big iron too. It doesn't have to be a small one. And you drag it across the pads, and then you look at it with a magnifying glass, see if you got any bridges.
That YouTube video you gave us had a good example of them drag soldering in it.
And I've done some of that because the pins are so close together, even under magnification, it's hard to see them individually. Yeah, that part's doable. That part's solderable. I've done it. Did it on a project. I had. It was an expensive chip too. I think it was about a $30 chip. Why are the hard to solder ones always expensive, right?
Of course, Murphy's Law.
That's it.
Gives you great motivation to make sure you magnify it real well and validate you don't have any jumps.
Oh yeah, yeah. Let's see. Let's see if we got that in the component editor. Search all libraries, SI4707. So pretty much everything we're doing tonight is not really building on other stuff that we covered, but it's important because I'd rather download a part than create one myself. That's time consuming. It's doable, but it's time consuming. And you'll see that in the video. And there's two different parts. Let's see. This one's in user components, and the other one is in components RF receivers. That's where I found the other RF receivers. It was under components RF receivers. You look in that library. So here's the one I downloaded. If we open that component, and they've got a different layout. I didn't compare pin for pin to see if all the pins were there, and you could, if you don't like where a pin is on something, you could take it and put it on the other side of the part. Let's turn that guy around and let's put it over here because it makes my schematic look better. And then you can save that off. I'll typically put like a -1 after the part name, save it into a library and use it in my project because it's one that I've modified. Just make ease of use of and clarity of drawing my schematic. So what do you think? You guys all ready to tackle a board?
How long did it take you, Steve, to learn this program and laying this stuff out?
I used to use Express PCB and printed off artwork and did my own boards. And so I had some experience there. And going from one drawing program to another, it's kind of like going from one computer language to another. You've got different constructs, but the concepts are all the same, right? And the artwork evolved and things just got nicer and easier as I went. Anybody got any questions over what we've gone over so far?
A quick one. I mean, what's your experience with things like, do you find that most of the parts are well, what's the ratio of parts that I can trust? So I'm going to go put fuses and connectors and those, larger components.
Probably most of my experience has been with surface mount lately.
Okay.
Buying parts and putting them on boards and stuff.
Yep.
I have had 0 failures. I test the part and then I'll print out a layout of the board a little larger than life. And I'll test the part and I'll place it on that board or on that printout where it's going to go and how it's oriented. So I know I've tested all these parts and they're in the right place. And all I got to do is pick them up off that paper and place them on the board after I put solder paste on. And it makes things a whole lot easier. You're not trying to go back and forth and find out if you got the right part and all that kind of stuff. You've already tested them all. They're good. You got them in the right place. You got them oriented right. And then once they're on the board, you pop them in the oven and 5 minutes later, you got a board minus your other extraneous components. But yeah, I've had 0 failures on surface mount parts. Absolutely 0. Knock on wood.
Knock on wood, yeah.
Yeah. If you get a part in the wrong place, say like this chip here that I downloaded, maybe I want it in a different library. Here he is in other components. But you can right click on this and move it to a different library. Say you want to create a custom library. The concept that I want to get across is that up at the top here are a group of libraries. And it took me a while to kind of grasp that this was actually a grouping of libraries up here, and these were individual libraries down here. And so we could export this in as a separate library file, and I could email it to you, and you could put it into your drawing program and have it all ready to go. Or if I made a custom part, we could email that to you.
So in the top window, they're all individual
There
groups.
There are a group of libraries under other. Here's some under other libraries. Here's some under user components. And here's the internal components here.
Okay.
That one you can't modify. That's part of the part that comes with the software.
That's a fixed group.
That's fixed, yeah. But user components and other libraries, I believe you can modify both of those, or you can create your own in the library setup. If you get something in the wrong place, if you don't want it here and you wanted it under somewhere else,
you can move it. You can copy it.
You can move it. You can copy it. You can create your own another library.
Yep.
And click on that, and here's the name right there. And so I'm going to call it that chip, right? And then I can add the file. Third-party libraries, Mauser parts. There he is right there. And now we've got that part in that library. But don't be afraid to move things around. I was kind of jittery about it at first. I'd done a lot of work on projects and stuff and had a bunch of other library files out there, and I yanked them out for the sake of the class. And so now I've got to go put all those back, but it should be fairly easy. Yeah, play around with libraries, get real familiar with that. That'll save your bake. And I had some stuff on the weather radio in case you're interested in any of that. There was Arduino code, but we said that was under components, right? And what did I say? RF. And you know, unless you know what to look for, you don't always know that it's in here. Receivers. There we go.
Receivers, yeah.
And then you see this list here, but it's not any of the SI parts. Those are down here. So here's the 4707. But then that got me to looking at some other receivers. And here's one that's got an SOP package. And that's what I showed you. It looks huge, doesn't it? But this is a 1-inch wide board, I believe. Let me look at the dimensions on it again.
I think you said 1.5 inches.
1 1/4 square.
Yeah.
Width of 1 inch and 1 1/4 long. So it's 1 1/4 square inches.
Pete's.
Yeah, it's a 1-inch wide board here. So the pitch on this particular part is a little bit higher than this one. But that's a drag solder. This one you can solder individual pins if you want. But yeah, that got me to looking through some of these different receivers and stuff that they have, and they've got a ton of product. So which led me to believe that yeah, I might be able to build a weather radio with one of these chips here. Not using one of the square ones, that's for sure. Look at that sucker. All right.
So the problem that you've got with that little one is getting it placed.
Exactly, because there's got to be some paste that goes in the middle here too. See the 4 blobs of paste there right in the middle?
Yeah.
And there's the part highlighted right there.
Wow.
Yeah, and to get the registration right, you're not gonna be able to see that. I mean, these pins here, they're hard to visualize, but you can get down there with a loop or a microscope and look at those and tell if you got a solder bridge or not. Just hit it with some heat and some solder braid and lift that bridge right off there. Little flux. But yeah, I'm sold on reflow stuff. You know, that was a project well worthwhile. Very inexpensive to build. I think the proto board that I bought with the chip and everything on it was like $25 at the time off eBay. That I have used it a lot doing surface mount work. All right, well, that's all I have for tonight. I will send a email out with a link to those 2 videos. The ones who are using the pattern and part editor, and so you can create a part easily. So
Steve, I want to really thank you for all your time and effort.
Yes.
Very satisfying.
It was fun for me too.
Yeah, it's definitely very motivating.
This is stuff that's doable, even the small stuff. But I would start out with 1206 size surface mount stuff. If you haven't done any surface mount at all, those are very solderable by hand. That little radio. Well, you've done some, Mike. You know what those are like.
Oh yeah. I didn't really have. I was surprised. I didn't have any real problem with surface mount soldering. Just steady hand was my biggest problem.
Mm-hmm.
But I used your little hold down with a clamp and a toothpick on it, and a small tip on the iron. And flux is my friend. That's the one thing I've learned. Flux is your friend.
Yeah, I had gotten a flux pen. We were talking about building some radio called an RXTX ensemble. That's less than $100. It's a kit, and this thing is just packed with parts. You could wind your own coils.
Yeah, there are parts on both sides of the board.
Yeah, ports on both sides of the board. I got the kit and I turned it over and I'm like, oh, look at this. There's all this surface mount stuff on the bottom, and like, well, I'm in it now. So if I was going to build another one, I would put all the surface mount stuff on and reflow it, and then go do the rest of the stages after that fact. But that's when I got over my fear of surface mount, was with building that kit. That was a fun project, and I've still got the radio today. It's up here on the shelf, and then plug it into the sound cards and run what is it, JT9, JT65, FT8, and the digital modes on it. So some people run CW with it. A few people run phone. All right, well, that's all I have for tonight.
Thanks again, Steve.
Thank you again, Steve.
Like I say, reach out if you get stuck on something or have any questions.
Just to confirm, this is the last class?
This is the last class. Yeah, I don't have any more material for another class. This is all I know. I taught you everything I know. 5 easy steps.
All you need to know in 5 hours.
Like
Yeah.
making a cake here.
That's it. That's it. We didn't even break any eggs, right? Yeah, if you guys think of a project or whatever we want to work on together, and
I'll tell you, between the YouTube video of the RF and this stuff, it really seems like it's very, very doable.
all right, guys. Well, till
All
the next project.
All right. Thank you, Steve.
Thanks again, Steve.
right.
Everybody.
All right, thanks,
Everybody
Steve.
have a great evening. We'll see you
talk to
later.
you
Bye-bye.
too. Take it
Bye,
easy, Mike.
guys. Have a good night.
Take care, Ron.
All right, bye-bye.
Bye.